So we're going to continue talking about the p-value, and the p-value is going to indicate something to you, and it's actually indicating the degree to which the data are incompatible with what is expected. Okay, so how incompatible is the data? Now, we have to say it's what is expected if the null and the other assumptions that we have to make are true. So we're going to get this percentage that measures the incompatibility of the data with what we expect from the null if the null and all the other assumptions are true. So what is it not? What is it not? It is not the probability that the null is true. We'll never know for sure if the null is true. So this measurement isn't saying that's the probability the null is true. It is not. It's the probability that the data are incompatible with the null. How good is my evidence? So a small p-value is going to indicate that the data, which again is our evidence, is unusual if all the assumptions that we need to make to run this test, such as the null, are true. So we have to make these assumptions, and we really don't know if the assumptions are true or not. That's why we have to do some assumptions, and that's why we have errors. So a small p-value indicates the data is unusual. So if I have a small p-value, how small is small? Remember, we compare it to the alpha level. So if my p-value is smaller than that, this indicates that the data is unusual for this, so it's telling me that I'm not supporting the null. So what does it not mean? It does not mean the null is false. Remember, we're just getting evidence. We don't have all the evidence, so you can't say that the null is true, and you can't say it's false. It's either supporting or not supporting. So this would be a not support. Okay, so you either support or not support. And then large p-value is going to indicate the data, otherwise known as the evidence. What is it going to say about the evidence? Is not unusual if all the assumptions, including the null, are true. So it just is an indicator. Okay, this means that it is going to support the null. So it's just an indicator. What should I do? So that means I have a larger p-value. So for example, if my alpha is always going to be 5%, that's what we'll always use. And my p-value is equal to 15%. We would say that this indicates that the data is not unusual. It indicates that it probably could come from the data set that would describe the null if all my assumptions were true. So what does it not mean? It does not mean the null is true. Okay, it's only supporting or not supporting based upon the size, and not only the size, but the comparison to the alpha level in which you set. So we have some questionable things that can happen when using a p-value to make decisions. That's why the p-value is not going to be used all the time. We use this thing called a confidence interval. So we have this thing called data dredging. So what we're going to do is we're going to make decisions that affect the p-value. Maybe I want to take a bigger sample size, but we do this after the data is collected. Maybe I change from being not equal to being greater than or less than. This is not ethical. This is something we don't do in statistics, although lots of times it's done. So we have to be really careful about that. And the other thing is significant chasing. So what we do here is we do multiple testing until we get the results that we want. So basically we just need to run one test. We need to have everything set up, and what we get is what we get. We can't just go and modify things to make it seem or appear what we want to have happen. So here's an example. Let's suppose that I have my weight of my packages in my product. That's what the manufacturer said that they should weigh. And I'm assuming that the manufacturer is going to give me more. I'm using an alpha level at 5%. I look at my z-score. I find that it is equal to 8%. And so I'm going to make a decision. So when I compare these on a number line, here's my 5%, my 8% falls in the support region. So even though it seems like it's a small value, I can tell 8% is near as good as 32%. So I know that it's close to this, so it's not supporting it a whole bunch, but it does show support. So we would have to say at the alpha equals 5%, the p-value, you always want to know your p-value. How strong is that p-value supporting or not supporting my null? The p-value of 8%, what does it do? It supports the null. It is small, but not small enough. So it supports the null. What is it supporting? The weight of the packages is approximately 28 grams. That's supporting my null that said the packages should weight 28 grams. Another example, let's suppose I've got my chips, my chocolate drops. So we were advertised that there were supposed to be 15 chips in each cookie, and I'm assuming they're going to give me more because there's a lot of dang cookies out there that are chocolate chips on the market. We're going to always use this. That's always just going to be a given, but you have to state it. And let's suppose I find my p-value to be 3%. So what's happening as a picture, if this was 15 chips, maybe I'm way out here, okay, and that's a 3%. So what's happening here is that I would, at the 5% alpha level, the p-value, so you want to report all of these, the p-value of 3% does not support the null. Okay, so what does that mean? The number of chips, or chocolate drops, if you will, appears to be greater than 15 drops. So you have to state what is it you're supporting or what is it you're not supporting, at what level and at what p-value.